Complete solution of mathematics for class 10 under the syllabus of Board of Secondary Education Manipur. Solved, recorded and edited by I. Salam Meghasundar Singh, lecturer, Sursan Higher Secondary School, Imphal. Chapter 10, Trigonometry. Article 10.6, relationships between the trigonometric ratios. Trigonometric ratios sing marakta lainaba relationship. Ahanbada reciprocal relations. We have sin A is equal to opposite side divided by hypotenuse equal to BC by AC. ABC is a right angle at B. AC is called hypotenuse, AB is called adjacent side, BC is called opposite side of this angle A. Then sin A is opposite side divided by AC, which is equal to BC divided by AC. Also, cosec A is equal to hypotenuse divided by opposite side, which is equal to AC by BC according to this figure. So, cosec A is equal to AC by BC, which can be written as 1 by half BC by AC. But BC by AC is already found to be sin A. So, cosec A is equal to 1 by half sin A, or sin A is equal to 1 by half cosec A. Similarly, sec A is equal to 1 by half cos A, or cos A is equal to 1 by half sec A. And cot A is equal to 1 by half tan A, or tan A is equal to 1 by cot A. Hariba relation ahum natraga relation 6 asi trigonometric ratio singi marak lainaba relationship reciprocal relation singadoni. Next, quotient relations. Tan A is equal to BC by AB. Opposite side divided by adjacent side, that is BC by AB, which can be written as BC divided by AC whole divided by AB divided by AC. But BC by AC is already found to be sin A, and AB divided by AC is cos A. Tan A is equal to sin A by cos A, and similarly cot A is also cos A by sin A. Therefore, tan A is equal to sin A by cos A, and cot A is equal to cos A by sin A. These two are known as quotient relations in trigonometric ratios. Article 10.6, trigonometric identities. In triangle ABC right angle at B, ABC is right angle B, and consider the angle A. Applying Pythagoras theorem in this right triangle, we have AB square plus BC square equal to AC square. Here AC is the hypotenuse. Dividing in its term by AC square, we have this, and which can be written as AB by AC whole square, which is also can be written as BC by AC whole square. AC square divided by AC square is 1. But AB by AC is cos of this angle A, which is cos A, and BC divided by AC is also but opposite side divided by hypotenuse, that is sine of angle A, and which can be written as sine square A plus cos square A equal to 1. This relation holds for every A such that A is lying between 0 degree and 90 degree, including the two ends. Again, AB square plus BC square equal to AC square. Dividing in its term by AB square, we have this. AB square divided by AB square is 1. BC by AB whole square, which can be written as AC by AB whole square. But BC by AB whole BC by AB is square is tan of angle A, and AC divided by AB is sec of angle A, which can be written as 1 plus tan square A equal to sec square A. This relation holds for every A such that A is lying between 0 degree, including 0 degree, excluding 90 degree. Again, AB square plus BC square equal to AC square. Dividing in its term by BC square, we have this. AB divided by BC is, which can be written as this. BC square divided by BC square itself is 1, which can be written as AC by BC whole square. But AB divided by BC is adjacent side divided by opposite side, which is cot of angle A. Similarly, AC by AC by BC is cosec of angle A, and which also can be written as cot square A plus 1 plus cosec square A. This relation holds for every S such that A is lying between 0 degree and 90 degree, excluding 0 degree and including 90 degree. The above three relations are known as Pythagorean relation of trigonometric ratios. Article 10.7 Trigonometric identities. An equation is called an identity if it is true for all values of the variables involved. Equation amada yauriba unknownsing adugi value pumnamakna equation adubu chumhalabadi madubu identity kawi. An equation involving trigonometric ratios of an angle is called a trigonometric identity. Unknown angle amagi trigonometric ratios yauba equation amabu trigonometric identity kawi if it is true for all admission values of the angle involved. Angle pumnamakna yauriba angle adugi value pumnamakna madubu chumhalabadi. Exercise 10.2. Question number 1. In a right triangle ABC, right angle at CAC is given as 3 cm, AB is 5 cm. Find the value of sin A cos A, sin B cos B. Solution. Right triangle ABC, right angle at CAC. The length of AC is 3 cm and that of AB is 5 cm. These are given as in this picture. Right triangle ABC gives AB square equal to AC square plus BC square, which is from the Pythagorean theorem, Pythagoras theorem. Then AB is given as 5 and AC is given as 3, but BC is to be found out. Solving BC, we have 4. So therefore, sin A is BC by AB, that is 4 by 5. Cos A is equal to AC by AB, which is equal to 3 by 5. Then sin B is AC divided by AB, which is equal to 3 by 5. Cos of B is BC by AB, which is equal to 4 by 5. Thus, values are found out. Question number 2. In a right triangle DEF, right angle at E, DF is 13 cm, DE is 12 cm. Find tan D minus cot F. Number 2. Tan D minus cot D. Right triangle DEF, right angle at E, DF is 13 cm, DE is 12 cm. Right triangle DEF gives, applying Pythagoras theorem, we have hypotenuse DF square equal to DE square plus FE square. Giving their respective values, we have this equation. Solving FE, we have 5. Tenth of D here, tenth of D is this. We have to consider this angle. This is adjacent side, this is opposite side for angle D. Therefore, FE per opposite side divided by base DE, which is equal to 5 by 12. Cot of F, cot of this angle for this cot angle is this base adjacent side divided by opposite side. FE divided by DE, which is equal to 5 by 12. Cot of D for this angle, cot of D is, this is adjacent side, this is opposite side. The DE divided by FE is equal to 12 by 5. Therefore, tan D minus cot F, tan D whose value is given as 5 by 12, and cot of F is found to be 5 by 12. Their difference is 0. For Roman number 2, tan D minus cot D. Tan D is 5 by 12. Cot D is 12 by 5. Sum up, we have this. Again, sum up, we have this. Which are the values to be found out? Question number 3. If cos of angle A is 3 by 5, calculate sin A tan A. Cos A is given as 3 by 5. We have to draw roughly. This is cos A. If this is A, this is B, this is C, then here cos A is 3, which is 3 by 5. We have cos A is 3 by 5 using this trigonometric identity. We have this, and cos A is 3 by 5. Solving sin A, we have this. We have to take sin A only positive value. Here we don't consider negative values of this. Similarly, tan A sin A by cos A, using this quotient relation, sin A is found to be 4 by 5, but cos A is already given as 4 by 5 or 3 by 5. Cancelling 5, we have 4 by 3. Thus, we have find out sin A is 4 by 5 and tan A is 4 by 3. Tan A is 3 by 4. Find cos A, cosec A. Tan A. Let us draw a right triangle. And consider this is called A. This is the angle. This is B. This is C. And tan is 3 by 4. Tan A is 3 by 4. Using this trigonometric identity, we have this giving tan A is 3 by 4. We have this equation solving sec A, we have 5 by 4. Sec A is equal to 1 by of cos A using the reciprocal relation between them. Then cos A is equal to 4 by 5. For using this trigonometric identity, we have this giving their respective value and solve sin A is 3 by 5. But sin A is equal to 1 by of cosec A. Relationship between sin A and cosec A. And cosec A is equal to 5 by 3. Thus, we have find out cos A and cosec A using trigonometric identities in respective portions. Without drawing, we can draw this roughly. Question number 5. If sec A is 13 by 12, find tan A and sin A. Sec A is given 13 by 12. We have to find out sin A plus tan A and sin A. Firstly, we have to use the sec tan identity. Then sec tan identity is giving the value of sec A, that is 13 by 12, and solve tan A, we have 5 by 12. But sec A is equal to 13 by 12, whose reciprocal relation with cos A is 1 by of cos A. Solve cos A, we have 12 by 13. After finding out cos A, and we have to find out sin A. Let us use the identity relation between sin A and cos A, that is sin square A plus cos square A equal to 1. Giving the value of sin A cos A, we have this, and solve sin A, we have 5 by 13. Thus, tan A is already found to be 5 by 12, and sin A is also found out 5 by 13. 6. If cot A is 4 by 3, find the value of cos square A minus sin square A. Cot A is 4 by 3. Using cot cosec identity, we have this, put their respective value and solve cos A. Cos A is 5 by 13 or 5 by 3. Cosec A is 5 by 3, whose reciprocal relation with sin A is 1 by sin A. Solve sin A is 3 by 5. After finding out sin A, we have to use this trigonometric identity sin square A plus cos square A equal to 1. Giving the value of sin A and solve cos A, we have cos A is 4 by 5. Thus, we have find out sin A and cos A. We have to use this in the given expression, that is cos square A minus sin square A. Their cos A give value the 4 by 5, means whose square is this, minus 3 by 5 whole square. Solving, we get 7 by 25. Question number 7. If tan theta is A by B, so that this expression equal to A square minus B square by A square plus B square. Tan theta is this. Left hand side of the given expression is this. Tan theta piriba si sin theta amasung cos theta ge expression ni left hand side si tan theta tanabagi damak aikoina cos theta na divide taroni mathaki tang khudingmak amasung makhagi tang khudingmakta. Cos theta na yale mathakidi A tan theta laire minus B laire makhagidi A tan theta plus B laire. Tan theta ki value A by B as official as simplify torasi, we have this. This is the exactly equal to right hand side. Thus, the statement is proved. Question number 8. In a right triangle PQR, right angle at Q, PR minus PQ is 1 cm and QR is 5 cm. Find the values of sin R, cos R, and tan R. In a right triangle PQR, right angle at Q, PR minus PQ is 1 cm and QR is 5 cm. Is in this picture, QR is 5 cm. It is given PR minus PQ is 1 cm. Their difference is 1 cm. right triangle PQR, applying Pythagoras theorem, we have PR square equal to PQ square plus QR square, giving their respective value. PR is equal to 1 plus PQ. PQ remains unchanged. QR is equal to 5. And so expand this and cancelling the two equal terms from both sides. We have this. Solving PQ, we have 12. PQ is 12. PQ is 12. Their difference is, therefore it must be 11. Also, PR is equal to 1 plus 13, 1 plus 12 equal to PQ. PQ is 12. PQ is 12. PQ is 12. One more. This must be 13. So sine R is sine R of this, sine of this is perpendicular divided by hypotenuse, 12 by 13 sine R. Matlab next is cos R, adjacent side divided by hypotenuse, that is QR divided by PR equal to 5 by 13. Next tan R is opposite side PQ divided by adjacent side QR, whose values are 12 by 5. Thus the value of sine R, cos R, tan R are found out. Question number 9. Express cos theta, tan theta, and sec theta in terms of sin theta. Cos theta, tan theta, and sec theta sing asi sin theta da phungdu. Firstly, we have to use sin square theta plus cos square theta equal to 1. This is trigonometric identity. Solve cos theta. We have this, which is cos theta is completely expressed in terms of sin theta without involving other trigonometric ratios. Next, tan theta is sin theta by cos theta. We have tan theta is expressed in terms of in quotient relation, but cos theta is just found out is square root of 1 minus sin square theta. Thus, tan theta is expressed completely in terms of sin theta. For sec theta, so theta is equal to 1 by of cos theta, but cos theta is found out square root of 1 minus sin square theta. Thus, we have expressed cos theta in terms of sin theta, tan theta in terms of sin theta, sec theta in terms of sin theta. For question number 10, determine whether the following equations are identities. Makhagi identity equations sing as identity over puthu. Taking theta equal to 30 degree, we have left hand side equal to cot square of 30 degree plus cos 30 degree. Cot 30 degree is root 3, whose square is this, and cos 30 degree is root 3 by 2. Simplify and solving, we get this. For right hand side, sin square of 30 degree, but sin 30 degree is half, whose square is 1 by 4. Left amaso right right value anis never equal makhoi ani manadre. Therefore, left hand side does not equal to right hand side. Apiba particular theta ki particular value amana trigonometric equation sibu chumandre. Value trigonometric identity higher gadi theta ki unknown angle dogi oithopia ba value puna mon chumangada bane mafam asida particular value amana chumandrabadi machi trigonometric identity ama oidre. Hence, it is not an identity. If theta is chumabadi 30 degrees na chumlabadi, atopa 60 random low raga yengani aikhoina. Determine whether the following equations are identities. Let us take left hand side is this. Sin tan theta the quotient relation of kongdoni solve torani aduga matha amasu makhadagi common factor sin theta logtokrani. Common oriba term factor matha amasu makhada common oriba bracketed factor si kakhakrani mabani chap mane. No. Ani CD manadre. Then sin theta so sin theta so kakhakrani, we have 1 plus cos theta by 1 minus sin theta. Sec tahan ge hairabadi cos theta na matha amasu makhage term khudimukti yelani. 1 by cos theta is sec theta ne. Sec theta plus 1 by sec theta minus 1, which is right side, which is equal to right hand side. Left hand side and right hand side tahanwa ngamlabadi piramiba equation asi identities or trigonometric identities or. Hence, it is an identity. For Roman number 3, left hand side is this. Sin theta, tan theta is quotient relation of punto sin square theta animaktagi logthokre cos square theta 1 minus cos square theta di sin square theta ni sin square theta amaga tan cos square theta amaga ani combined tawra, we have this. Then this is tan square theta into sin theta. Machine right hand side to yaure. Left hand side to right hand side yaropong. Hence, it is an identity. For Roman number 4, tan phi cosec phi equal to sec phi. Left hand side equal to tan phi into cosec phi. Tan phi asidi sin phi by cos phi ni, cosec phi di 1 by sin phi ni, sin phi ani si kakthanakrabadi. Sin phi mathak leba sin phi common factor of makhage kakthana we have 1 by cos phi, which is equal to sec of phi, which is right hand side. Hence, it is an identity. Question number 11. Prove the following identities. Identities single C left right command prove to. Left hand side is this. Then we have to multiply 1 plus cos theta in numerator and denominator. For numerator, we have this. For denominator, applying a square minus b squared is a plus b whole into a minus b, whose product is this, which is equal to sin squared theta. Taking out square, we have this, which is equal to 1 by sin theta plus cos theta by sin theta. 1 by sin theta is cosec theta, cos by sin is cot theta, which is right hand side. Hence proof. For Roman number 2, left hand side equal to this. Mathaki 1 plus cos a asigi magi rationalizing conjugate amana purirani 1 minus cos a divided by 1 minus cos n mathak amasu makhada purirani. Mathaki damakta 1 minus cos square a fange masi aikoina amo 1 sin square a da thamani, sin a sin a kathak thrabadi mathakta sin a amu lemhori adudi masi hojik aikoina yore irosi right hand side yore. Left hand side na right hand side tahanwa ngamle. For Roman number 3, left hand side is equal to this. Sum up, we have this. Sum up the denominator is equal to product lerani cos square a plus 1 plus sin a whole square. But the expand of only we have this sin is cos square a amaga sin square a amaga sum up the 1 lere hanege 1 jigari 2 ni 2 plus 2 sin 82 comma log we have this. Maka asidege kuno lengana thamani. Then 1 plus sin a ga makhagi 1 plus sin a ga common factor and common factor and is 2 by cos a phange, but which is equal to 2 sec a, which is the right hand side. Hence proof. For Roman number 4, left hand side equal to sec square theta plus cosec square theta. Tahangadori will see sec square theta into cosec square theta ni. Sec square theta di 1 by cos theta manai, cosec theta di 1 by sin theta ga manai. This sum up tauravadi aikoi masi phangani mathak ase identity 1 ga manaba identity do oire 1 tare masi amuk product to phungdokane asumna 1 by cos square theta into 1 by sin square theta masi di kalare sec theta ga manai 1 by sin theta di cosec theta ga manare hoji right hand side adu yaure. Hence statement identity trigonometric identity ase proof tore left right ga manai habedu. Roman number 5, left hand side is equal to 1 plus sin theta by 1 minus sin theta. 1 minus sin theta ki conjugate, magi conjugate na mathak masu makha makta puriyani makha ki damakta di 1 minus sin square theta phange mathak ki di 1 plus sin theta whole square. Mathak ase expand lengana thamasi makha ki di cos square theta. Trigonometry identity seasonary square common logthokrabadi we have this. Machi so amuk 1 by cos theta plus sin theta by cos the result to kawi. Asumna samda phongdokpa si 1 by cos theta di sec theta ga manai, sin theta by cos theta di tan theta ga manai. Masi di exactly right hand side to hence the trigonometric identity is proved. Roman number 6, left hand side equal to this. Mathak ki minus leiba asigi magi rationalizing amana puri gadra hoji koina 1 plus cos theta sigi magi rationalizing na puri rabadi mathak si 1 minus sin square theta mathak the grouping same gare. Maningda leba tam amaga mamangda leba tam amaga anisi combine tawkhrabadi we have cos square theta phangani. Mathaktagi cos theta common logthokrabadi si phangani. Hojik common factor mathak amasu makhada common oiba non-zero factor ani yauri masi pathakrasi. We have cos theta by sin theta, which is equal to cot theta, which is right hand side. Hence the trigonometric identity is proved. Roman number 7, left hand side equal to this. Sum up, we have this. And makhagi sidi cosec square theta minus 1 phangani mathaki di cos theta ga sigi cos theta twice cos theta cosec theta minus cos theta ga plus cos theta ga kakhana gare. Makhagi cosec square theta minus 1 di cot square theta ga manai cosec amasung cot ke identity seasonary. Cot theta asi amuk ꯃꯊꯛꯀꯤ cosec theta ꯑꯁꯤ 1 by sin theta ꯗ ꯐꯣꯡꯗꯣꯛꯑꯕꯗꯤ cos theta by sin theta ꯗꯤ cot theta ꯅꯤ cot theta ꯃꯊꯛꯀꯤ ꯑꯃꯒ ꯃꯈꯥꯒꯤ ꯑꯃꯒ ꯀꯛꯊꯅꯈ꯭ꯔꯦ ꯃꯈꯥꯗ 2 by cot theta ꯅꯤ 1 by cot theta ꯗ tan theta ꯗ ꯐꯪꯂꯦ ꯃꯁꯤꯅ right hand side ꯇꯨ ꯑꯣꯏꯔꯦ hence proof. Number 8 left hand side equal to this tan theta ꯗ ꯐꯣꯡꯗꯣꯛꯀꯗꯕꯅꯤ ꯃꯁꯤ ꯑꯩꯈꯣꯏꯅ ꯄꯤꯔꯝꯃꯤꯕꯁꯤ divided by 1 1 ꯍꯥꯏꯕꯁꯤ cos square theta plus sin square theta ꯍꯥꯏꯕ sin cos ꯌꯥꯎꯕ identity ꯑꯃ ꯁꯤꯖꯤꯟꯅꯔꯦ ꯃꯊꯛ ꯑꯃꯁꯨꯡ ꯃꯈꯥꯒꯤ ꯇꯥꯝ ꯈꯨꯗꯤꯡꯃꯛꯇ cos square theta ꯅ divide ꯇꯧꯔꯁꯤ we have this and masana masari ꯌꯦꯜꯂꯕꯗꯤ 1 ꯐꯪꯉꯦ sin theta by cos theta ꯗꯤ tan theta ꯅꯤ ꯑꯁꯨꯝꯅ ꯁꯤꯒꯤꯅ 1 ꯐꯪꯉꯦ ꯁꯤꯒꯤꯁꯨ tan square theta ꯐꯪꯉꯦ ꯃꯁꯤꯅ right hand side ꯇꯨ ꯑꯣꯏꯔꯦ hence proof. Number 9 left hand side equal to sin power 4 theta minus cos power 4 theta masi asumnasu amuk hana iba yai sin square theta whole square minus cos square theta whole square masi expand torobadi we have this han factory 1 ga managare si lemore masi right hand side or hence proof. 10 left hand side is equal to this 1 by 10 a se kaya ka manai cot a ka manai asumna 1 by cot a su 10 a ka manare masi trigonometric identity sizinarabadi no quotient relation sizinare 10 a gi sin a by cosine sum up torabadi mathang makai 1 manakre masi amuk product form do phongdo ani cos square is sin ngata da tahangadabani sigi cos square is 1 minus sin square a thamkare product phongdo left right hand side exact yore which is equal to right hand side hence proof. Number 11 left hand side equal to this 1 ama tan square sakro 1 amana cot square ka grouping semgro cd sec square a ga manare cd cosec square a ga manare sec tan ga identity sina cosec con ga identity sizinaragani now ji ani se amo 1 by reciprocal relation da phongdo ni sum up torani mathak si 1 ga managare makha cd 1 by cos square a की product into 1 by sin square a which is equal to sec square a into which is cosec square a which is right hand side hence proof. Roma number 12 left hand side is equal to this mathak si a cube plus b cube की formula पांगनी करम formula a cube plus b cube whose factorization form is a plus b whole into a square minus ab plus b square. We have to use this formula. We have this. Then sin square a plus cos square a square plus b square the punna thangna equal ani si 1 lairani. Then c ki common factor ani si makthana krani si common factor si never 0. Then we see c ki over c is now 1 ga mana kare 1 ga mana we have this which is right hand side hence proof. Then left hand side equal to this makhagi plus minus level c plus level amana puri rani plus level mathak to makhazu puri ro makhagi di 1 plus cos theta na a square level minus b square side square theta level mathak actual multiply taro ba matung da c gi cosiliba ani sina 1 amaga lere adudi hanega 1 ci ga 2 lere we have this 1 ama lejagre hanega 1 lejagre then mathak ke c expand taro sigi cos square theta ga siga kana grouping sigi 1 siga siga grouping ama same krasi we have this makhagi expression asi phangle sigi 1 minus sin square theta di cos square theta le cos square theta ani gi twice to go 2 lokto cross sigi 2 siga kaktanare this by this phange then amuk su mathak kisi factorize toro makhasu common factor lokto koro cos theta 1 plus cos theta na mathak kitam khudi makti yelabadi we have 1 plus sin theta by cos theta which is right hand side hence proof. Roman number 14 11 give 14 11 side equal to this ani sum up to quotient relation that 10 a amasung cot ac quotient relation da pungo m the denominator asi sum up tore denominator gi denominator da mathak ta cos square ac gi sin square a makhagi ani si manadri minus the canary ama minus kam lokto ko si ahan bagi sidigi minus 1 lokto we have this mathak to minus 1 puriro makha ani si manahale mathak ani do muk asuna tarani mathak ki factorize toro, that is sin a plus cos a into sin a minus cos a, divide toro body we have sin a plus cos a, which is right hand side, hence proof. Roman number 15, left hand side equal to this. Then a assist sin a by cos a, cot a assist cos a by sin a, also puncto bracket manung sum up toro adu common factor sing adu khona lotokrasi sidagi common factor sin sida puri badi sin a bracket manung gi ani si manabra manadi. Then sidagi di khona mathak ki tam sing asi lotokraba mathak ki tam ani si mathak ki factor ani si mani si lotokraba di sigin sin a by cos a, cos a mas mangon do thamorani sin a by cos a mas laire, then cos a by sin a to thame. Then mathak kisi sum up torasi mathak kisi 1 ka tare 1 tare this by this phangani, this by this the mahana si younger but si phange. Next si lerani 1 by cos a di sec a ka manare, 1 by sin a di cosec a ka manare, hence right hand side yaure, hence proof. For Roman number 16, left hand side equal to this. Sec a su reciprocant cosec a su reciprocant loina thamasi sin a na puri syllabary we have this signal 1 layer since the puri syllabary 1 layer since the puri minus the puri plus layer, then ani si minus 1 ga plus 1 ga kathana kare ani is the sum of toro with mathak to trigonometry identity 1 ga manaba ama phangle, then cd 1 by cos a into 1 by sin a the pungoni 1 by cos a sec a ga manai 1 by sin a cosec a ga manai, right hand side yaure, hence proof. Thanks for watching.